Okay, hello students. Here I'm walking through the uh, task from Unit 5, Algebra to Unit 5, lesson number 2. Um, so the learning target is let's represent vertical and horizontal translation using function notation. So I can use function notation to represent a vertical or horizontal translation from one graph to another. So let me straight away go to the student's task. So this video is about student's task. That is, there will be 2.1, 2.2, and 2.3, and then the cool down. So let me straight away open this page, and here you go. The first one, lesson number 2, moving function. So first is what happened to the equation. Now I want you to check on this. So this one is given. This part is given to you. This function is given, and they give another two functions, that is hx and gx. So what you're supposed to do is remember this function is like a cubic function where you can see the zeros here is x equals 0 and x equals 2. Uh, so this is the original equation, and they say let's see what do you see the difference from the given equation, which is f of x, to this equation. Okay, pause the video for a while and see if you can decide it yourself. Okay, now watch this. This in this equation there is a x square. So first there's x square, and in this equation also there is x square. Okay, and then there's x minus 2. Here also x minus 2. So what do you notice is only that extra negative 5, right? So you see this extra negative 5. So in other words, whatever the f of x is, so the hx which you see is hx is equals, and this whole thing is uh, this part is the same as this part, so it's the f of x. I'll put it like it is the f of x. Okay, and then they add the minus 5. So you get adding, it's minus 5. So it's me adding minus 5. And whatever the value of f of x, you take away minus 5, and that's how you get hx. In other words, the graph. So you can decide what the graph will look like, but we can also put it on the Desmos. Let's put it on the straight away desmos.com. So let me put here, and the first equation is f equals x to the power 2 and then x minus 2. So that's the one. And the second equation is gx is the same thing. X minus 2. So I think I made a mistake here. Let me put, okay. Okay. So this was the original equation, right? See, if I click on this, it's the same thing. The purple and the green are the one and the same thing. So what I do next is you take away 5. So you subtract 5. So what did happen was, let me minimize here. You can clearly see the graph. This green graph has shifted a little bit bigger so that I can see everything. It's too big. Okay, here. So that means this is 0, 1, 2, 3, and 4. So the purple graph has shifted 4 units down. Every point, let's say this is the point, which whatever the output, let's say this is the output, you add minus 1, minus 4 here, and you'll end up getting that minus 5. See this one, you add minus 4, you get that part. So this point, let's say this is 0, right? The output here is 0. Origin, it is the 0. But then you add negative 4. So that's why it becomes negative 4. So what do you say here? What are you supposed to write here? Just write down. Let's see if I can text here. Let's see, can text. So mm, let me put just this one maybe. Okay. So the size, background font size is okay. So what happens is the gx, the g of x is the graph, is the translation of graph f of x of f of x shifted shifted 4 units down. See, so that's the gx. And if you see the next one is the hx. So if you go back to that, let's see, let me go back. I wanted to write the other one in this graph itself. Let me see if I can type here, but I have to use the. I have to exit. No, I don't want to exit. I just want to type in here. Oh, I did. Oh, it went off. Okay. So now in the next one we put hx, and what is that hx says is x squared, x to the power x. Sorry, it's x. It's x, but then it's x minus 4 minus 4, and then go to the power 2, and then there is a x minus 6. And then I'll take off this gx and see so what's going on. You can clearly see. Let's take 1 point, just an easy one. Let's take 2. This is the original 2, 0, right? And clearly you see that there's x is replaced by x minus 4. So what you are adding is to the input. So here the input is minus 4 is added. This is the extra. And in this case, this was x minus 2. And to x minus 2, you add minus 4. Sorry, I'm talking about this one. This is minus 2, and if I add minus 2 and put minus 4 there, you get back this. So just imagine I add right there on top. If I put minus and 4, and you can see then the f of x. So this one x minus, I have to change both. So what's happening is you're adding minus 4 to both the inputs, and that's how you get the graph shifts. Now look at this 2. The value for the green graph function f of x, f of 0, see, f of 0, sorry, f of 2 is 0, but here f of 6. Now watch this, so beautiful this is. This is 2 comma 0, and that is 6 comma 0. It means how the graph is, when will the graph be same as the green graph is? It means if 6 is 0, that means the green graph, the output is already 0 4 units before. So that means this two has shifted, this point has shifted 4 units to the right, and that's how this x minus 2, which is right here, this becomes x minus 6. Again, I repeat, let's take that off and think of the origin, this point. This point was 0 0. Now the point is 4 0. So that means initially it was just the x, but now you're adding minus 4. So that means the value of the black graph, that is the H graph, the output is 0 for the black, but the green graph, the output was already 0 4 units before. It's already being done. So only thing the green, the red, the black graph, it's going to be output before 4 units later on. So that's why you see that's minus 4 here. So what is this minus 4? Just to show that the hx, the output of hx, that is the 0. This is the output. Sorry, this one. This is 0. Uh, but the output here is 0. But the green had already been done. Output 0 long back, 4 units below. So it's the same thing like a time. Maybe if something is another example was shown in the class. Why do we put x minus 4? So if this is x right here, and this is x minus 4, and you can clearly see why you put minus 4 is because the red output is 0, but then the output was 0 4 units before. That's why I put x minus 4. And you can also see this one is x equals 0, and if you put x equals this 4 right here, 4 minus 4 is 0, and whole thing is 0, and that's how f of x equals. So we can write a nice relation and say, okay, h of x is the same as f of x. And the only difference is it's like the input are changed by writing minus 4. That's it. So that was the task number 1. Let's go to the task 2. Okay, this is 2.2. What it says is the question says this graph is F graph and this graph is the G graph, and it clearly shows that G is the vertical translation. That's what the question says, a vertical translations of the F graph. So the question is, you need to answer questions by just looking at it. You can clearly see a lot of things going on here. Let's imagine, let me think of one point. Let's take this point. Look at this point 2. This was 2 comma 0, right? This was 2 comma 0, and that 2 has gone here. So it was 2 here. So this was 2, the same thing, but then it shifted up here. So that means this point has gone 1, 2, 3, and 4. The same thing, if you see this point, the point right here, it has gone 1, 2, 3, and 4. If this is the point, it has gone 1, 2, 3, and 4. So this point here. If this is the point, it has gone 1, 2, 3, and 4, and that's how you got this point. So clearly sees it goes. Let's see what is the question is. So let me take this off. The question is complete the, so where is that complete gx. Now let me get the table if I can pull this out. In the table what they say is, let me write down here. Okay, I'll go back to that. So if you see this, they asked us to complete the gx column, then they ask if f of 0 is this, then what is g of 0, and explain and how you know. So let me go directly to the spreadsheet that I did. So this is x. The first column is the input of for the function f here. So those are -4, -3, 2, and 1 point. You can see -4, -3, minus, and let's put it -4 is 0, so that's 0. -3 is -5.8, so that's I put -5.8. 2 is uh, -4, -3. I think I missed something here. -0.7, then 1.2, and then 2. So for negative 0.7 is 0. That's on the x-axis. 1.2 is right here, which is my negative 3.3. And this one is 2 comma 0, so let's put 0. So what they're asking us is g of x. So that's the function g of x, and another one is h of x. So the question is complete gx. So let's put gx. So this is the graph of gx. So what happened? What is this point? And you can clearly see each of these points has shifted for you up, right? So this has gone up. And the best thing you know why is because this itself I showed you also why this has moved 1, 2, 3, and 4. And you can see that's 4. So if 2 is 0, and here 2 is 4 here. So what we can write is every time if you are adding plus 4, so it is like 0 plus 4 is 4 here. And negative 5.8 plus 4. So let me write also this. How did we get this? Let's put it is 0 plus 4 and alpha equal 4. This is negative 5.8, and you're adding plus 4, so you get negative 1.8. Then check with the calculator. Oh, sorry. I think I should write it here. Negative 1, negative 1.8. Then this one will be, then this is 0 plus 4 again. So 0 plus every output of fx, you add 4 to it and you get output for gx. See, if it is 1.2, so you add, it was negative 3.3, so you add negative 3.3 and you're adding plus 4, and that will give you 0.7. I can clearly see the answers. That's negative 3.4. 1.2, so this is like 1.2, and that's the point actually. And the next one is again 0 plus 4 equals. So this takes care of uh, how do I shift this to the right side? Okay, hx. Oh, there you go. This is what I wanted to show. Now hx is, so how do I relate this gx? So the next question is asking if f of 0 is, so you can see when x was 0, if x of 0 is negative point, so I'm going to add one more. Uh, if x is negative 0.86, is asking, so sorry, so it's saying if f of 0, that means the input of this one is 0, is negative 0.86. Okay, he's asking, so what do you think is gx? So here very clearly shows here this point is if minus 0.86. So what is g of 0? So what is this point you're asking, right? So all you do is you put negative 0.86 and you add plus 4, and you get answer as, so that will give you the answer as 3.14. You can check with the calculator. There you go. So this is how you find that question. They also ask is how do you know? It's because every time the output of f of x, whatever the output of f of x, you are adding a 4 to it. That's why. The next question is asking, there is a hx, he says, and it gives you hx is already gives you equals f of x and then minus 2.5. And what it means is every time, whatever the f of x, so this part, let me put those, see if I can, how do I change it? This column, if I can change, I wish I knew everything here. I wanted to make it red color. So this thing, this is the output for this f of x. And I say minus 2.5. It means that this part, you just take 0 here, this 0, and put minus 2.5. And when you minus 2.5, you get negative 2.5 each time. Now this time it is minus 5.8. So minus 5.8, you add negative 2.5. And that will give you minus 8.3. Check with the calculator. Now again 0 and this 0, so everything, this will be 0 again, 0 plus 0 minus 2.5 will give you minus 2.5. Even this also will be same thing, 0 minus 2.5 equals minus 2.5. Only thing you have to write, this one was minus 3.3, so it is going to be minus 3.3, and then again minus 2.5, and that will give you minus 5.8. And then this one was minus 0.8. Okay, they did not ask you there, so we are done here. So that means the graph shifts 2.5 below or down, you can say. And if you want to sketch this, so what I'm going to do is maybe okay, let me see if I can do right here. Is this graph we will have to take down. What I'm going to do is, here it is. So let me try. everything goes down. So uh, this point, so this is -2, this is -3, -4. So this point, which is right here, has to go 2 units, 2.5 down. So that will be 1, 2, and somewhere halfway down, somewhere here. So this will go right here, somewhere here. This point will go somewhere here. The top one, see, the top one will go 2.5 down. That will go somewhere here. This will go 1 and 2 and somewhere here. And this point will go 2 down, so somewhere here. So your new graph will be going this way. Okay. Oh, I forgot about this. This will go 1, 2, and somewhere here. I think I did. Then goes down like this. Cool. And there you go, and done. So everything goes 2.4 down. So I hope that helps. What is the goal of the synthesis of this activity is for you to know that anything to the function f of the original function, this was the original function, and this function output, whichever the outputs are there, okay, you add something to it, to this output, then it goes up. So that's how the graph had gone up. The blue, let me, this was the blue which went up by 4. But because after that they ask you -2.5, I mean this graph, which was the original, goes down. So that's this one. So I think I made a slight mistake here. I tried to bring the G graph 2.5 down, and that's my mistake. So let me take off this everything. Okay, so this is the graph. It has to be taken down, not the G graph. So anyway, at least now you got an idea exactly how to go about is this point. Let's say this is -4. It goes 2.5, so it goes right here, 2.5 down. This point will go 2 point down. This will go to somewhere here. This will go 1, 2, and a little somewhere here. This will go 1, 2, and so this is how the graph will be. It goes down. Okay, so that's how the graph. So everything goes down below 2 units down. So the goal is here h of x, the new function was, original function was f of x, and you put -2.5. So that's the understanding of how this works. Write an equation of gx. This we did, which was the gx, that means this graph was the original graph, and you add +4 to it. That's it. That was the answer over there. Let's move on to we sketch also to next is 2.3.